Recording.
All righty. So best thing I would say for everyone to do is you can read the chapter in the book ahead of time. So when we come into the lecture, it kind of helps to expand, and we'll kind of remind you with that through the modules. The modules are set up to where you do one at a time, and it'll open up as you finish that module. So I'm going to try to have all the quizzes ready. So, you could kind of self-pace yourself there as you wish. But let's get into Unit 1 and Chapter 1 here. And share my
Right, okay. You know how to do it? Or don't touch that.
Don't touch it. Yeah.
We got it.
Is it over here, man?
Yeah.
Okay.
Hello, how do we turn down the volume?
Okay, in the lower, the little volume thing at the bottom of the screen, by the clock, if you hover your mouse there.
All right, so we're covering Unit 1 first, and we're doing kind of a chapter each week. Some weeks we'll spend a little bit more than one day on a chapter, 2 days on a chapter. Might kind of bleed over. I'm happy to pace this as you guys need, so just keep that in mind. So Unit 1, Chapter 1, we're talking about the history, trends, issues, and challenges in plant science. And we're going to start off here with the history aspect. And you'll see that throughout these lectures, I've kind of highlighted some of the key terms. Those are the ones that you really need to pay the most attention to. And in the modules online, you'll see the unedited PowerPoint as it came from the book, as well as the edited version, which I've highlighted just so you can see some of those differences. The book is not always up to date on all the issues, so share some insights with you there. So anyway, talking about the history of agriculture and plant science and technology. Really, if we think about it, many of the plants evolved, before humans had, anything to do with them. So many of those plants 150 million years ago are very similar that we have today, the wild plants. It's the cultivated plants that we've changed. I'll just throw out the mention of the term here, angiosperms, and that basically just means the flowering plants. That's a group of plants, and we'll talk about this in more detail later on, but it's just the group of plants that has been the most successful in terms of colonization of land, and just happens to be the largest group of plants and where most of our crop species are, but not all of them. That's the flowering plants, and that includes grasses as well, fruits, trees, and shrubs too. I wanted to point out here early on in our history that modern man, of course, is, we think of the term Homo sapiens, our species, right? They say around 28,000 years ago. That's debatable, of course, depending on the anthropologists. But either way, what I want to point out here is that for most of the time that human beings have been on planet Earth, right? We were nomadic hunter and gatherers. So really, biologically, we've evolved to hunt animals and gather plants, whether we use them for food or fiber or shelter. The books suggest that it's about 10,000 years ago that agriculture began, but really, if you look a little bit further, some anthropologists suggest that it's more around 14,000 years ago, and that it didn't happen just overnight. It wasn't just one single event that led to the cultivation of plants. It was many different events over time in different places. So they say around 14,000 years ago is when we began the purposeful cultivation of plants. And it started all around the world kind of around the same time, 14,000 to 10,000 years ago, and some later on. These agricultural practices, though, when we developed them, we changed this whole paradigm. It's this shift from being hunters and gatherers to actually being more sedentary and starting civilization, stopping moving as much and beginning to stay and plant fields and grow crops. Which also then begins more commerce. We had trading before, but now we have more to trade, more of one product rather than lots of a little bit of a ton of different products. So from agriculture comes commerce and really civilization as we know it anymore. The agricultural revolution, as we mentioned, 10 to 14,000 years before present, occurred around the world, kind of around that same era. And a plant scientist, Russian plant scientist Nikolai Vavilov, suggested that there are about 8 centers of origin. And this is from the research that he has done. He did in the early 1900s, looking at where these crops originally came from. And he later postulated that these centers of origin of these plant crops are also the centers of diversity. So if we look on the map here, we have these different areas where our modern food crops originated. And that's kind of based on where their wild ancestors still exist today. Another map here I'm going to show you is a little bit more expanded. So he actually started with just a few centers and then expanded it. Anthropologists for a long time said that it all began there in the Fertile Crescent in Mesopotamia. And you can kind of see that that is still kind of considered, here, Western Asia, is still considered one of these, very important centers of origin. And the reason that it's well known is because it's one of the foods that came from antiquity. We think of wheat. You can come on in and sit down if you want. We actually have class in here for today. So, yeah, take a seat. So we have a new student joining us. So anyway, the agricultural revolution is occurring around the world, and the work of other scientists, they basically gathered this work and kind of built upon it. So here now we have centers of origin also in North America, in the Caribbean, in tropical South America, West Africa, all of these different food crops that we know today, coming from different places where their wild ancestors still exist today. So take a look at this map and kind of try to recognize where some of these things came from. So the big one in Western Asia, being things like our grains, wheat, barley, rye. In Southeastern Europe, or what Vavilov knows as the Mediterranean, we had things like peas, barley, some temperate fruits, onions, beets. In the southeast, south and other Eastern Mediterranean over here, other different crops. Central America, more tropical crops. In the Andes, the New World, we have things like tomatoes, potatoes, beans. In Central America, we have corn. So nonetheless, just throwing out where this came from. And then these crops, of course, were moved around the world. And as civilization developed, we kind of have this divide that we, came up with today, where our urban citizens, the people living in the more populated areas and city centers, are becoming less and less aware of how the crops are produced and used. So we have this interesting rural-urban interface, as we know, is kind of an issue today, where we don't always have this great connection and understanding of how agriculture is conducted in the rural areas, but most of the foods are actually consumed in the urban areas. As the agricultural revolution took place, we have this issue of supply and demand, of course. And as the plant products demand increase, the cultivation methods that develop to help to keep production up. So that comes with the age of metal, right? So we started developing farm implements. So it goes from just replanting seeds to the development of technology. Taking a step back here, we're looking at kind of the study of agriculture and also horticulture. So we look at the fields of agronomy and the fields of horticulture as being different. I kind of think of them as being similar, except agriculture being kind of the umbrella, agronomy being more the field-grown kind of commodified crops that have lower inputs and are more extensively used. So we think of agronomy like fields of corn and soy. Horticulture being more intensive production. So we think of that as being like vegetable crops or fruits, ornamentals. So anyway, just a slight difference there, although really there are a lot of these gray areas where these disciplines overlap. Horticulture and agriculture, we think of horticulture as being a subset of agriculture. If we think about Virginia, if we look, we were talking last week about the top 5 crops in Virginia. The horticultural crops kind of encompass number 5, like it's this whole area. But really, there's a lot of kind of bleed over in the field crops from agriculture or agronomy and horticulture. So we're going to talk about the different trends and issues that affect plant science. And one of the big ones is just the economics of it. So if we think of like horticultural crops, for instance, some of those might have that gray area where it's not just that money is exchanged for a product. It could be that money is exchanged for a service. So we have any golfers out there? Oh, anyway, you play golf, you're paying not necessarily for a product, right? You're paying, well, although of course you are for the golf balls and clubs, and et cetera, but you're paying for the use of this maintained turf field, basically. That's kind of this gray area where horticulture comes in and where it kind of changes the economics. But when we think of the classical economics, we're thinking of this balance of the supply of the commodities and the demand for them. And one of the things that emerges as an issue in plant science and technology, especially today, is this mismatch between the ecological value of our crops and the actual monetary dollar value of the crops. So looking at some of this throughout history, one of the issues that is, I think, most obvious is just the poor uses of soil. So in the 30s, we have the issues of soil erosion due to mismanagement of the soil over time, which created this whole soil conservation service, kind of born out of this whole Dust Bowl experience. So this is just an example of using plant science, this research and education, to try to merge that divide. So we're trying to figure out a way to kind of get the money value and the ecological value together. And this also brings up to the issues of sustainability. Can we continue to produce crops without affecting the future generations' ability to produce crops. And there's a lot more to it than that, and we'll get in more depth in that later on. But just right now, thinking that it's a little bit more than just the money aspect. It's the money, it's the environment, it's the social aspects as well. We also have the issue of financial speculation and analysis. And this is mostly for our commodified and subsidized crops. But we also have to think about new crops. So there are actually, we have more crops, like we were talking about hemp last week. It's starting to emerge as a crop on the financial analysis markets. So speculation over those crops today is, and how the yields will be, affect the price of these commodities. So that I feel like is something that really highlights this, kind of divide, but also how it's coming together, this issue of plant science looking not just at the growth of the crops, but also the economics of it. We also need to look at the balance of energy and resources. And really, for something to be sustainable, we need to balance the inputs and outputs. So this is something that we should always think about whenever we're producing a crop, whether it's for an animal crop or a plant crop. Whatever energy you put in, whether that energy is water or nutrients or fuel in terms of plowing the soil and preparing the soil, when we export that crop, we're moving that energy in a way, especially talking about the water and the nutrients. So trying to create a sustainable ecological relationship, we need to figure out ways to put that energy back in. And how we do that now is just through the return of profits, the return on investment there, getting that money and turning that back into more inputs to put in, which could be fertilizer, could be some sort of form of irrigation. We take it away, we got to put it back. Highlighted this term here, emergy, energy with an M instead, and basically that just means embedded energy. And really what we're looking at here in terms of our crops is that the embedded energy cost doesn't really match up with the actual price that you pay in the grocery store often. Kind of an interesting thing to think about. And it really, if you look at this, this is coming from a study in 2002, so I'm not going to say that this is, correct by any means, but it's just one scientist's, look at how, we end up paying a lot less for something than what the energy is embedded for it. Like, for instance, this seems way off to me, but for eggs, $62 for a dozen is the calculated price of this scientist from all that embedded energy into that unit. Fortunately, we don't pay that, right? So that's where things like subsidies come in, for instance. The embedded energy takes into account the tools that are used to produce it, any kind of enclosures. So let's just say we're looking at greenhouse tomatoes. That would be the embedded energy is the cost of the fuel to heat the greenhouse, the cost of the trellising to support the tomatoes, the cost of moving that crop from the greenhouse to the market, and so on and so forth. It's kind of hard to think about that. How do you price something considering the embedded energy in it? If we look at the kind of historical prices in the U.S., ag commodities fell in the last quarter of the 20th century pretty heavily. And as the yields increased, there was a decline in the per acre income. Again, kind of going back to that whole issue of supply and demand. we have more of the supply, but the demand remains the same and the price is reduced, which means that less and less money ends up back in the hands of the farmer. So another issue in plant science and technology is how do we get more of that back into the hands of the producer? So subsidy payments are one way of doing that. Unfortunately, that doesn't always work out that way, right? So the way that subsidies have worked in the U.S. is really to encourage consolidation. And one Secretary of Agriculture famously said, "Get big or get out." We wanted larger farms that were producing more, and we gave them more of these subsidy payments to get them to produce more because they're producing more of this product, the greatest amount. That's why we see this trend of larger and larger farms and fewer farmers. So number of farms decreased, the size of the farms get larger, the number of workers greatly decreased. The average now being about one full-time worker for each farm. However, there being, in some cases, many part-time workers. Another trend overall is the area of farmland kind of declining. And one of the things that we're seeing, in response to this is actually the regrowth of forest land. So I don't know how it looks over there in your all's area, but around here, there's a lot of abandoned farmland. And it's, what happens in the eastern U.S. when farmland is abandoned, it starts to go back into woodlands. The unfortunate part of that for us is that the woodlands that are growing back are mostly, because of the disturbed soil, mostly of invasive plants that are really not marketable. So we're getting like poor regrowth of timber in many cases, unless it was intentionally replanted. So that's in contrast to a lot of other countries. The U.S. is seeing that increase in woodlands. And we mentioned last week that in Virginia, we're looking at about 30% of the land being woodland. All right, another big issue, both in the U.S. and worldwide, is the population increase. Probably one of the biggest issues that we have to face in agriculture. How do we feed a growing world population? So in the U.S., most of the population increase is occurring in the urban areas. So we get lots of growth in the cities. We actually get less or a decrease in rural communities. So in 1900, we had 60% of the U.S. population in rural communities. And in 2000, it decreased greatly to 25%. We're looking at that, by 2050, they say that could be as low as 5%. So it's dramatically decreasing. And it's alarming, right? Because we need people in rural areas because that's where our farmland is. Now, one of the advents of technology is that there is more urban agriculture taking place, which, you can see that as a good thing or a bad thing, where there's less embedded energy if it's produced closer to the source. But at the same time, what about where the bulk of the food is produced on the perimeter, or far away from these urban centers? So although we classify it as urban development, this population increase, it's really actually more occurring as suburban development, kind of the peri-urban areas. So with that, this lifestyle of living in suburban areas depends on a lot of embedded energy, which greatly increases our energy demand. So we have population increasing, we have energy increasing. We don't necessarily have food crops increasing, though. So some things, and take this with a grain of salt here, but we think of the bad parts of suburban sprawl, but there are also opportunities presented with suburbs, right? So back to the whole golf thing. Golf alone, they actually say that in the U.S., turf grass is our #1 irrigated crop. So golf is equivalent to about 2/3 of major crop sales. It involves 12% of the U.S. population. And that's kind of just a result of suburban sprawl and how you like that, the recreation aspect associated with it. So horticulturists involved in the golf trade, there's money to be made there. That's another way to get more money back in the hands of the producer, although there are many consequences as a result of that. Another issue in plant science and technology, the rising cost of fuel. As we use more of that fuel and as the supply is decreased, then the costs increase. And that is unfortunately to a very large detriment to the farmer. It costs a lot of money to run equipment and to keep up with that equipment. So another thing that we had to look at in plant science and technology is how do we continue to develop the same crops with less fuel? So we need more, fuel efficiency. So two of the biggest issues in the global environment are the same as they are in the U.S., and that's the increase in human population and thus also the energy use. So we're having exponential growth of population, although that many, population scientists suggest that is supposed to stabilize around 2050 at about 9 billion people, compared to about the 6 or 6.5 billion people that we have today. So with 2.5 or 3 billion more mouths to feed and that much more energy to use, how do we do it in a sustainable manner? And how do we continue to make money off of agriculture? So even though the population is not doubling, they project the energy use will double. And that's because of economic development. So right now we see that it's the developing and developed countries that use the most energy. So if we think about like China and India, which are these rapidly developing nations, they're using more and more of that energy. And as we shift from being undeveloped and economically speaking, kind of poor countries to becoming obtaining more wealth, we shift the way that we use that energy too. So this just highlighting here that as people become more affluent, they tend to want to change their diet. And in that case, we're talking about eating things that people like to eat more of, right? I mean, meat products, especially processed meats, steak and eggs, making me hungry here. Dairy products. As that increases, the demand for energy is, outpacing the population growth. So it's not a 1-to-1 ratio there. And that in turn affects the world's food producing capability. All right, so one way that we deal with that, and this kind of goes back to why it's important to study these centers of origin and centers of diversity that Nikolai Vavilov set out. And the big thing there is the development of plants that utilize less nutrients to produce greater crops. So we look at plant breeding. Initially, in the agricultural revolution, we think it was probably a mistake. With Vavilov's research, it's used to take the germplasm, those centers of origin and centers of diversity, gain the genetic advantage of the wild relatives, incorporate things like disease resistance or drought tolerance into the crops by breeding. So we get this term, cultivars, or cultivated variety. So in the 60s and 70s, there were all these, projections from scientists saying that we are on the brink of famine. We have lower fuel availability, increasing costs in it. All this kind of came to a head. And at the same time, there was this kind of second green revolution occurring where scientists and researchers were breeding higher yielding varieties of these food crops to help with that. And it did. So that's how we're still able to maintain or increase our yield, feed more people off of less land. China's a big user of our agricultural crops. In Virginia, actually, the greatest user of our agricultural exports. I'm sure you guys have probably heard in the news a lot about, the whole tariffs and trade wars thing. And you also hear a lot of that, affecting agriculture greatly. And that's because China has, actually today more than 20% of the world's population, but less than 7% of the world's cropland. So in 1950, they say it had about 0.2 of a hectare per person. And now we're looking at 0.08 of a hectare. A hectare is about 2.5 acres. If we're looking at the U.S. units there. So, if you think about that, 0.08 of a hectare is very little land per person. China cannot feed itself, so it relies on us. And is it what we do? Is that enough to feed them? So we're inextricably linked because of that, and this just highlights how our agricultural economy has become globalized at this point. Along with that kind of globalization, I'm just going to highlight here. This is coming from the book. Whether you guys believe in global warming, climate change, whether you believe that it's human cause or not, I think you do have to recognize, it's been scientifically proven that it is occurring. And how will that affect how we produce crops, as well as how we produce crops affect that? So there are lots of ways that we affect the climate through the production of crops. They talk about CO2 a lot, but there are other gases like methane, for instance, that are very noxious and that are kind of accelerating what we call the greenhouse effect. So climate change is another one of these really big issues in plant science and technology. How do we deal with that? While we have these issues, the demand for food and fuel continues to increase. So if we look at tropical countries, another prescient news thing here, the deforestation of tropical forests. So we'll talk about this in more detail later on. But right now, we know that tropical forests are a major sink of carbon dioxide. When we remove those trees, and we take a look here at this satellite imagery just from the other day from Brazil, you can see that in the Amazon where these wildfires are burning, it started with a clearing of land. So they are still conducting slash and burn agriculture down there. And you see these cleared areas of land adjacent to these fires because that's where it started. I think that's something that's not really being shared in the news. It's not just a forest fire. Tropical forests don't typically, catch on fire, right, on their own. It's the act of clearing the forest for agricultural land that is causing these forest fires that we're seeing right now. Either way, it's another thing that is feeding that fire. It's on there, but feeding the fire of the whole climate change issue. It's all about the money, right? So again, globalization, our international trade with tariffs and duties on these imports and exported crops has created kind of an interesting economic paradigm. In some ways, it can be good, right? By exporting crops, that we might be able to exploit value as supply and demand in another country to get more money back in the hands of the farmer. That's a good thing. However, there are lots of side effects of this globalized trade. And one of the big ones are just the whole issue of pests and diseases. Since we're moving these crops around the world, we're also moving the pests and diseases associated with them. And there are so many different examples of that we can talk about, and we will talk about later in more detail. But I think one of the big ones here in the eastern U.S., like chestnut blight, for instance. We don't have any more American chestnuts, and that's because we imported, probably for ornamental purpose, an Asian chestnut, and on it came this chestnut blight and destroyed much of the what was once this very important tree in the eastern U.S., both for timber and for food. Now, another thing to look at in terms of globalization, and I haven't seen much of this issue really being developed, but to say that bioterrorism could be a major threat to agriculture. And, how do you stop that? So it highlights in the chapter, a few examples of bioterrorism. None of them were actually proven to be, actual bioterrorism, though. However, it is an issue to think about, globalized trade. All right, so again, how do we find ways to meet our current and future needs without negatively affecting the environment? That's kind of one of the biggest challenges in plant science. And there are lots of different ways that we can start to address that with technology, with breeding of crops, and also with genetic engineering. So there's a lot of debate here with genetic engineering and genetic modification. And I just want to highlight that the better term to use here is genetic engineering. That's the what is occurring in labs, basically, where we're taking the genes from one pool of organisms and moving them into a plant, what we call transgenic production. One could argue that genetic modification has been occurring since the agricultural revolution, right? We, modified the genetics of these crops through breeding. So I feel like GMO is not the best term to use there. It should be genetic engineering. It's a little bit more accurate because we're actually intentionally changing the gene pool. And I think there are lots of potential merits for genetically engineered crops, but there are also lots of concerns. And that's something that just has to be weighed and examined on kind of a personal basis. We'll actually have a little discussion online about that. In the book, it does point out some of the genetically engineered crops. It does a pretty good job of that. Most of what we regularly consume in terms of vegetables and fruits are not genetically engineered. And you kind of see this whole, I kind of call it greenwashing, really. These schemes saying, oh, this product is GMO free, it's certified GMO free, right? Well, those crops aren't even genetically engineered anyway. So it's just a labeling scheme, I think, to try to make more money. Hey, which is okay, right? Again, one of our goals is trying to make it economically sustainable, getting more money back in the hands of the farmer. So one thing that a lot of scientists look at is organic or ecological agriculture as a potential solution. However, I would point out that again, there's a lot of debate around organic. One, it costs a lot more. That could be good for the farmer. It could be a premium pricing opportunity to shift to organic because you can use that to get more return on your investment. However, there are many organic practices that can still have negative environmental impact. I just want to say that I think we do too much vilification of these things. So genetic engineering, not good or bad. It's just another technology. Organic farming is not necessarily good or bad. It's just you have to weigh that on a personal basis. I think they're all potential tools in this toolbox for us to figure out how we're going to feed a growing world population with less energy and less inputs. So I'll just cover one more thing here before we end in a minute. And basically that's another challenge in plant science is just getting the food to the people. We have hunger and starvation occurring globally at the time. However, it's not because of a shortage of food. It's our shortage of the ability to get that food to the people that need it. So it's mostly due to these social and political issues that prevent that distribution. So that's why we have to take this broad approach in looking at it. It's not just the production of the crops themselves, it's how do you get the food to the people. One last slide here. I just want to point this out, and again, I'm going to try to get this up for you guys today so that you can go back and look at these slides. But these are the genetically engineered crops that are on the market today. We've got Roundup Ready crops. We have BT crops that are naturally synthesizing basically this bacteria that destroys pests. And we also have some crops that have been genetically engineered to produce different vitamins. And these all have different merits, but again, they have to be weighed, I think, on a personal basis. The good thing about Roundup Ready crops is that it allows you to produce more crops with less inputs, ideally. However, we're using more herbicide. With genetically modified corn, it could have unintended consequences to other Lepidopterous larvae. So that's a big pest, right? But what about those that might land on that crop? Could they be affected by the BT? The idea of genetically engineered rice that produces beta carotene, vitamin A, the golden rice that we're going to give, basically areas where children's eyesight has been affected by a deficiency in vitamin A. That's a great thing, right? But at the same time, couldn't they just, use other traditional foods that have vitamin A in them? So it's a lot more than just the black or white, right? We got to look at the gray area in meeting these challenges in plant science. So on that note, we're out of time. Sorry, I went a couple of minutes over. You guys just check on the modules there. I'll try to send out an announcement through Canvas when you should be able to see them, just so someone can test them. And I'll be in touch with Tom too about that. So thank you for your attention. I know that's a lot to cover in a little bit of time. We'll finish the rest of that on Wednesday.
Okay.